For you, in this video we are going to talk about the equation of motion of a mass on a ramp when a certain F is applied, so that the mass can accelerate up the ramp with a certain constant velocity. There are many videos made, there are many cases made last time. Please try to get the other videos that discuss about the motion of mass on down a ramp with constant acceleration, or a motion of a mass up a ramp with constant velocity, and how to determine the coefficient of friction on a rough ramp, and how to find out the minimum amount of force again when a certain effort is applied on the ramp. This is very helpful expression for your other related fields like work done, simple machines, and others are related. So this is a very important video to focus on the the dynamics of a ramp, gonna appear in other topics like in work energy, in simple machines, and others. Let's dive in. Now some forces are applied. There's a mass here M, so the mass M is just pressing the surface down, and the angle of inclination is theta. As we know, the horizontal line, this line is inclined by theta, and at the same time the vertical line is also inclined by the same theta. Now, so what is the different forces acting on these things are, so there is a force pulling up down with a certain force here, and the mass is moving up. Since the mass is moving up, so the friction is reducing, retarding your motion downward. And for any ramp, as we have already mentioned previously, the weight is the sine component. The sine component of the weight is always down to the ramp. So the force F applied, this force is supporting two forces. The supporting forces are, the main equation is the force minus the friction minus the weight sine theta, mass times gravity times sine theta. The weight sine theta is this one, and the friction is also downward, and the difference of these force, all these forces, gives you the resultant force. The resultant force. But we know frictional force is defined as the coefficient of friction times the normal force, and for the ramp, a normal force is the weight times mg times the cosine of the inclination. Then your expression for coefficient, for friction, is, for this guy, gonna be the coefficient of friction times the mass times gravity times cosine of the angle theta. So the force applied minus friction minus mg sine theta is equal to the resultant force. So instead of the friction, we are using this one. So equation of motion gonna be the force applied minus the mu times mass times gravity, which is the friction force. We have already derived the expression for that. So minus the mass times gravity times the sine of the angle, gonna give you mass times acceleration. Okay, this is the resultant force. So you may be asked to calculate the resultant force, the acceleration, the normal force, and so for the frictional force. So you have to know that the frictional force is not only the direction of the frictional force is changing for upward and downward. If the mass is sliding up, the friction going to be downward, and if the mass is sliding downward, the mass is gonna be, the friction gonna be, if the mass is moving downward, the friction is upward. Friction always opposes you, right? Opposes you. The frictional direction is always opposite to the direction of your motion. It resists this motion. So this is if the mass is moving down, the friction is upward, and the weight, the sine component of the weight, is always down the slope. Every time the sine component of the weight is down the slope. Now we have this expression. So how do we get the resultant force? As we have mentioned above, the resultant force is equal to the applied force minus the frictional force, which is mu times mass times gravity times cosine of the angle. So the resultant force is supporting them. This is the frictional force mu mg cos theta minus the sine component of the weight. Sine component of the weight means the sine component of the weight is mg sine theta. Yes, mu times m times g times cosine of the angle. So this is the expression for the resultant force. Okay, you applied this one to calculate the resultant force, meaning the net force up the ramp, this force. So the forces acting here is the weight sine theta, the frictional force is downward, the force applied is upward. The difference of this applied force and these two forces is giving you the resultant force. It is it. Let us see things in detail. For regarding to a ramp accelerating upward, so we have expression for a normal force. The normal force is equal to how much? The cosine component of the ramp. If the mass is like this and the weight is vertically downward, so the mg cos theta is crossing the surfaces together, so the Fn is always the cosine component of the weight, and there is a sine component of the weight, mg times sine theta is downward. So usually this is the mass, so usually the normal force for a ramp is this component of the weight, the mass times gravity times the cosine of the angle. This is the expression for the normal force. The other thing that you have to focus on is the frictional force is the coefficient of friction times the normal force. This is the definition of frictional force. Okay, but you know the normal force is changing based on how you are applying a force. If this is a case, if you are applying a force like this, so the normal force, if this is a support and this is a mass, the normal force is simply the weight. And remember the other thing, if this is the case and you are applying a force like that, so this force, this applied force has x and y component. So this is fx, that is fy, then the weight is down, so you subtract the detaching force. So this component of the force is detaching, the downward is attaching. So what is the normal force? The normal force is in this case the weight minus fy. Okay, the other thing that you should focus is the Fn is if it is acting something like this, then this is the mass, this is the support, and this force is acting at some angle, so this force is a pushing force, so there is a y component here and the weight is attaching here. So this time the normal force is the sum of the fy and the weight. Yes, so in ramp, in inclined plane, your normal force is always mg. So we did the expression. So the normal force is mg cos theta for ramp, and the definition for friction is coefficient of friction times the normal force. But the expression for the normal force is this one. Then you do the F normal, I mean the frictional force, the frictional force is equal to mu times the normal force is mass times gravity times the cosine of the angle. So this is how you calculate the frictional force. And the other thing is, in this particular case, the resultant force is how much? As we can see here, because there is a ramp, there is a force applied on the ramp, and this force is given, and the mass is accelerating up because there are two downward forces, the sine component of the weight and friction, and due to this, the mass is accelerating up because the applied force F is greater than the sum of these two forces, the sine component of the weight and the frictional force. So whenever you are required to calculate the resultant force, you do the applied force minus the coefficient of friction times mu times the cos theta, which is the frictional force. This is the frictional force. Then minus again, then the sine component of the weight. So this is how you find the resultant force. Lastly, how do you get the acceleration? So by definition, or by Newton's second law, the acceleration is the resultant force divided by mass. So this is the expression for your resultant force. So you do this is equal to F minus, I can take this minus common, and I can take mg common, mg into sine theta, sine theta plus mu times cos theta is the simplest form. So this gives you the resultant force and divided by the mass. Okay, when you divide every term by m, you're gonna get the acceleration is how much? The acceleration is, so the force applied over mass minus the mg over mass times the sine of the angle plus the coefficient of times cosine of the angle. So the final expression for the acceleration, you can cancel this by that. So the acceleration for such case is how much? There is the applied force divided by the mass minus the gravity into sine of the angle plus coefficient of friction times cosine of the angle. This is the expression. Let's do this one with some numerical example. Now in this example, you have given a mass. The mass is already given here. It is 24 kilogram mass, and the force applied is, the force is how much? It is 3 Newton, and the mass is 24 kilograms. The gravity 10 meter per second, cosine of 37 0.8, and the sine of the angle is 0.6. Now we are required, there is a force here, we are required to calculate the things like the normal force, the frictional force, the resultant force, and the acceleration. Now let's do the first, the normal force. So remember, the normal force is usually in ramp the cosine component of the weight. This is it. So this is mg cos theta, mg times cosine of the angle. So this is equal to, the mass is 24 times the angle, the cosine of the angle is 0.8 times the g is 10. So the result is 1000. This is equal to 1920 Newton. That is the friction force. All right, that's the normal force, sorry. So we have the normal force. Once you have the normal force, the definition of frictional force is how much? Frictional force is the coefficient of friction times the normal force. That is, the coefficient of friction is 0. How much is the coefficient of friction given? Or mu 0.4 is given. So that is 192 is the normal force times 0.4 is the coefficient of friction. The result is 76.8 Newton. Yeah. So this is the frictional force. And now we are going to calculate the resultant force is equal to how much? The force applied minus the frictional force minus the weight sine theta. So we need to calculate the weight sine theta. So the weight times sine theta is how much? The weight is 24 times 10 times 10. Sine theta is 0.6. So you have 6 times 0.6 times 10 is 6 times 2 is 144. This is equal to 144. So this is what? The mg. This is the mg sine of the angle. Yeah. So this is how you get the sine component of. Let's get the resultant. And the resultant is the applied force, which is F minus frictional force minus, so the sine component of the weight. So this applied force is 600 given. The frictional force is calculated as 192 Newton minus the weight, the sine component of the weight is 144. So let's do. So this is equal to 600 minus this 2 is, you can say, minus here 192 plus 144. You can do it. So this is the same as 600 minus the sum of these two is 136. 336. Then the resultant force is how much? 600 minus 336. Sorry, 336 gives you 264. So the resultant force which is responsible to the acceleration is 264 Newton. Yeah. So you have calculated the resultant force. So the last question is asking you to calculate the acceleration. From Newton's second law, the acceleration is how much? The resultant force divided by the mass. So that is 264 divided by the mass is 24. Yeah. So that is it. When you calculate this, 264 divided by 24 will give you 9.33 meter per second square. So this is the acceleration. Thank you for watching this video. If you subscribe and like this video, you will have a notification when a similar useful videos are posted. And please don't hesitate to share your friends. Thank you for watching.